Let's talk about our next non-primitive data type, objects. So what is an object? An object stores data as key value pairs. Each piece of data has a label called a key and a value attached to it. So far, every value that we have worked with has been a single or simple thing. A name, a number, a boolean. But what about data that naturally belongs together? Like a person detail, like his name, age, email, and all describing the same thing. Is it better to have multiple variables for similar kind of data? Or is it better to combine them and have all the data together that belongs together? And that is exactly what objects are built for. Let's actually see the code for our example. So you can see without using object, we can only store a single value in a single variable. And that way, if we had multiple values that belongs together, we had to use multiple variables for that. And now this is how an object looks like. Since we have all the data available for a user, we can call our object user, and then inside these curly braces, we have, you can say, the body of object. Now you can see that we have our object user, and inside we have multiple, you can say, properties, which are actually called properties, and they are in a syntax of key and value pair. So basically we will have a key to represent a value. And now let's talk about how we can access these properties. So normally if we had a normal variable, we could just do console.log and we could write the name of the variable. And it would print the name or the value actually stored in that variable. But on objects, we have two ways to access the properties. And the first one is called the dot notation. So if I want to access the name inside the user object, what I can write here is user.name. And this way I can access the value of name key. Now if I hit save and go back to the browser and refresh, we get back the error because we have to rename the variable. Now if I go back and refresh, you can see my name printed on the console. Now similarly, I can access the address property and I can see the address written inside this user object. So basically the address of the user, and I can print that on the console as well. So this was our dot notation, and the next one is called bracket notation. So as the name suggests, we can access this via the brackets as well. So if I write it like this and comment this part out, hit refresh, I can still see the address of the user. Now you might be thinking that why do we have two ways to access the property? And the reason is that we have the dot notation to access the direct property or the key of the object. But let's say we have a dynamic property in our object and we want to access that, and its value is stored inside a variable. So what I can say is let address key equals address, and I can just pass this variable here. And this will also work. But this is the difference I want to show you. We cannot do user.address. So actually let's print out this first and see in the console. So if I press refresh, you see undefined, because what this is trying to do is accessing the address key property inside the user object, which is not defined. But what we wanted to do is to use the value of this variable and access that on the object. So if I hit save now, go back to the browser, hit refresh, I can see my address again. So this is the reason why we have two ways to accessing a property on an object. By default, use dot notation, but switch to brackets when the key is dynamic. So keep that simple. Now a property can hold more than data. It can hold a function too, which is also a value. So when a function lives inside an object, it is called a method. And you might have heard me call methods previously. So how we can do that? Let's say we want to add a greet method. So what we would do is name the method greet and then define the function here, what it would do. So let's say we want to do hello. We can choose template literals instead of double quotes because we are going to print the value of a variable. And now you might be thinking how we can access name, right? User.name, that won't be working. So we have a special keyword here. We can use this. And this keyword is how a method refers back to its own object. So this refers to this object. And if I hover over this keyword, you can see we have these properties available. And what we want is the name. So this dot name. Now you can see that we have added a method inside our object. Now actually let's use it. So what I'm going to do is console log the return statement of this method. And in order to invoke that, we have to write the name of the object, dot, and the method name is greet. Now if I type it like this, hit save and refresh, you can see it is returning the function. So you have to make sure you are calling the function or invoking the function. And you can do that by adding the parentheses. Now we will execute the method and its return value is going to be printed on the console. So if I go back to the browser and refresh, you can see hello Hisan. And even if I change the name and go back to the browser, you can confirm that it is actually using the correct name. Now this is just one example. At the moment I think it might be a little bit complicated to understand reference, but you can see what is a reference type. Now object can also contain other objects, which is how you represent data with the layers of detail. And that is why I created these three variables for address. Now we want to store the address of the user in three different keys, not just one like this. So what I can do is instead of assigning a string value to this address property, I can assign it another object. And this is going to contain, let's say, the city, and city is Tokyo, and it can also contain country. So the country is Japan. And now in order to access these properties, I can just copy this dot notation, paste here. And if I now print the user.address, go back to the browser, hit refresh, you can see that we are being returned an object, not just a single value. And if I expand this, you can see we have two keys, city and country. And if we want to just access one of this property, we can use the dot notation further and access the city. So now we see the Tokyo in the console. Now in JavaScript, we have a lot of methods that are available on the object keyword. But I will just start with a couple that you should be familiar with early on, and we will keep exploring others as we progress further. So the first one I want to talk about is the object.keys. So let's say we want to get all the keys that are available in this user object. And how we can do that is, let's say iconsole.log. And here I'm going to say object, which is a keyword, dot, and I'm going to call the method keys. Now in the parentheses, we have to write the name of the object for which we want to find all the keys. So in our case, it is user. If I hit save, go back to the browser, hit refresh. So you can see we are getting back the list of all the keys that are available on user object, but they are also in an incremental way. And that is called an array. And what an array is, we will talk about it in the next video. But basically, object.keys gives us back the list of all the keys that are available on the object. Now, similar to keys, we have values. So for example, we don't want to have all the keys, but we want to have all the values of the object. So if I go back to the browser, you can see I can get the list of all the values, not the keys. Now another one that would make more sense right now, because we might need both the keys and the values of all the object properties, we have another method called entries. So let's comment this and use entries here. Now what it is going to do is it is going to return us the keys and the values. So both the keys and the values of that object. Now if I refresh my browser, you can see I'm returned list of arrays. Now if I expand this list, you can see we are getting back another list. So basically it is a nested list. And if I expand one of the items, we can see that 0 is pointing to the key and 1 is pointing to the actual value of that key. And it is true for all of the list element if I expand them. So the first is the key and the second is the value. So these are the three methods that I wanted to talk about early on. Now let's see how this actually works under the hood. Now objects are stored differently from primitive data types in an important way, and that is by reference, not by value. The primitive data types are stored by value, but objects are stored by reference. Now what does that mean? I've come back to the code and I'm going to clean all the code that we have written so far. And I'm going to use a very simple example here. So in this example, I have made one object user1 and it has one property called name. Now I'm assigning the user1 to a new variable called user2, which is also going to be an object. And now I'm just updating the name on the user2, not on the user1. And if we print user1 name, what do you think is going to be printed? Is it going to be Ben or is it going to be Sarah? So let's go back to our browser and see it in the console. If I refresh the page, you can see it is printing Ben. And that is because when you copy a primitive, you get a totally independent value. But when you assign an object to a new variable, basically they are referencing the same index in the memory. And this is an important concept. Objects are shared by reference. Changing one variable can affect another pointing to the same reference. Now coming back to our code, you might be thinking then how we can create two different and separate objects. And we have two ways to do that, a spread operator and object.assign. So let's see them one by one. Firstly, let's take a look at the spread operator. So instead of writing user2 equals to user1, what we are going to do is write curly braces, and inside them we will write user1. So the only difference this time is these three dots. And what we are doing here is basically we are copying the properties into a new object. And that new object is created in the memory, and that is assigned to user2. So now if I try to console log user1, even if I change user2 name to something like Ben, hit save, go back to the browser, refresh, and you can see the correct result, Sarah. So you can see that we can use this way to create two different unique objects. Now another way is to use object.assign. So I'm going to comment this and let's use object.assign. So how we can use this object.assign is we would write object.assign and it would take in two arguments. The first one is the object we want to assign the value, and second one is going to be the actual values we want to copy from. So we want to copy from user1 and assign it to a new object, and that value is going to be stored inside user2. So if I do this, go back to the browser, hit refresh, it also works in the same way. And if I do user2.name, hit refresh, you can see we print Ben. Okay, so let's enhance our example, and what I'm going to do now is add another property in the user1 called address, and it is going to be a nested object. So address is going to contain another property, city, and that is set to Tokyo. So now if I'm cloning user2 using object.assign, and if I try to update this city for user2, and let's say I set it to Osaka, I've also updated the console log to show the city of the user1. So in the browser, if I hit refresh, you can see it still says Osaka. But we didn't change for user1. We did update the city for user2, and we are also using object.assign. So why is this happening? Now here I want you to understand a really important concept called deep copy and shallow copy. So a shallow copy basically creates a brand new object, but it only copies the top level properties, or you can say the first level properties. The two most common ways to do this is by using the spread operator and object.assign, which we just used. Here is a catch though. Shallow means only the first layer gets copied. If a property's value itself is an object, like our address, then that inner object is still shared by reference. And that is the reason why we are seeing the city as Osaka for user1 as well. Now the other part, deep copy solves this problem by copying every layer. Doesn't matter how deeply it is nested, every object inside an object gets its own brand new copy. And the modern built-in way to create a deep copy is by using a method called structured clone. So I'm going to comment this line, and now let's actually use structured clone. And it takes an argument which is the object we want to clone, and that is our user1. So if I do it this way, save and go back to the browser, you can see the user1 address is still Tokyo and it is not being updated. Now all of this brings us to a very important question about shallow and deep copies. What we just did, does that mean we should always create deep copies? And the answer to that is no. Not every situation needs a deep copy. And the deep copies do cost a bit more performance since they have to process every nested layer. Now we have two scenarios, and based off that you can use either shallow or deep copy. The first scenario is if you are working with a flat data and there is no nested objects. Then you can go with shallow copy, because a shallow copy is simpler and perfectly safe for such kind of data. And if you're working with nested objects, you have to use the deep copy. When I first started, I faced this problem myself. And this also applies to working with arrays too, which we are going to talk about next, but the exact same rule applies. And that is all for this video. I know this was a bit longer one, but I want you to practice and learn about objects and get comfortable enough to actually use them when we are going to build an actual application. Now let's talk about another important non-primitive data type called arrays in the next video.